All right, so our guest speaker tonight is Lee Johnson, N4WYE. That ought to be a 1x1 call with N4Y, right? Okay, maybe not. But anyhow, he's going to do a repeat of the VNA, Network Vector Analyzer. Last month, he did this for the GARS general meeting. This month, or this meeting, he's going to actually test some bandpass filters that I handed to him so he could test those. And he's going to do a dipole antenna and then whatever else he's thought of. So Lee, take it away.
First of all, thanks again for the invitation. I enjoyed the first one, and I hope you folks enjoy this one. I'm looking forward to it, to giving it at least. One of the questions I got is, since we did the presentation, how many VNAs do we have in the audience? Somebody's got to count because I've only got about 6 on the screen.
I've got one.
I've got one too. K4.
That's 2.
I've got 1.
3.
And
I've got
got
one.
4,
I've got
5,
one. Brian.
Got one.
6, 7,
I have one.
8.
I've
Okay,
got
Mark has 1.
We got
I
any,
have-
are we having any repeats here?
No, I've got one. This is KF4KXO.
Oh, okay. All right. Okay, so we got a fair number anyway. I hope that you folks have had some time to play with it, make a few mistakes, curse it, and get to know it a little bit. Did most of you end up with the H version? The H4 inch version?
Yes.
Or we got a, okay.
No. Yes, I did.
yes.
3
Yeah.
gig.
Okay, so we may have some differences in the menus, but hopefully not enough to disturb anything. That's one thing I want to make sure of. Okay, good. I thought I'd go through and start with a couple of the operational aspects that might be useful, and kind of walk down through that, then talk about some basic measurements of what we've done before that most of the hams that I've talked to on the air seem to be most interested in, and also look at the filters. And I think Dallas feels like he got shortchanged on the 80 meter filter, and you'll see the performance here in just a minute. But we'll go through that, and then we'll go through and spend as much time as you folks would like to on an open Q&A. And we can do that however we want to, but I'm certainly willing to stay as long as you guys like. And if there's something I can't answer, then I'll take a note and get back to whoever had the question. You know, feel free to keep it informal. I spent a fair amount of time trying to get the screen large enough that you can see it. And if you make it full screen version, that's about the best we're going to be able to get. I think you'll find that you're able to read, if you're careful and have your bifocals on, the SWR number, the frequency number, the start and stop frequency of this chart. This is my InFed 40, 20, 15, and 10 meter InFed antenna SWR curve. And I just put that up there as a starting point. And the scan's going from 50 kilohertz to 30 megahertz. Okay, and the first line up where you see the 1 marker is the SWR equal 2 to 1. So you see most of the band does a better job than 2 to 1, or most of the ham bands anyway. But that's just a starting point. In general, one of the things I found out is that you got to watch out for this is the helpful hint part just to start with. You got to watch out for the connectors because they're really thin on the gold side. And as you put on the calibration loads, you're actually spinning the pins inside the connector. So you're going to wear out the plating on the connectors. So I've put on mine some of the, what I call connector savers, and this is what they look like. You can see them on there. See the bottom, and that's a connector saver right there. Okay, it just screws on the SMA connector on the unit. Okay, and so that way you can just throw these pieces away, you know, if they wear out. You don't end up taking the plating off this connector on the SMA connector on the unit. So that's just one helpful hint that I found out may be useful. Another one is on the menus. You know, a lot of us are used to being menu driven, and it's easy to get lost with the origin of where you started on the internet on the browsers, because you don't have any starting point. The nice thing about the menu system here, it's a firmware-based system, and there is a starting point that's always the same. So no matter if you get lost in making a measurement, you can always take the menu system back to a starting point that's the same. I'll walk you through that real quick. You just take and tap the right-hand side. By the way, I'm sorry you can't read that. I worked hard to try to get this, and Dallas and I tried hard, but we weren't able to get that the focus right. It's actually the lighting, and that's as good as we can get it. And I'm sorry that if I move it a little bit closer to the light source, it doesn't help it out a lot. And if I turn it off, then it blossoms out so badly you can't see the traces. So I think we're going to have to put up with it as a compromise.
You didn't have to say anything, because I would have thought in my case it was just my eyes being dilated from the eye doctor.
Well, I tried to get it right, but anyway, this is display, markers, stimulus, cal, recal, and recall cal, and close. And if you start, that's where you always start. That's the same screen, same set of menu options. And even if you're drilling down into the menus pretty far and get this screen pulled up, now see, that shows a little bit better. Get this screen pulled up and start drilling down into setting, you know, the start frequencies or whatever else. If you go back down to the bottom, and let me get out of this. Anyway, if you go back down to the bottom, you always get to the home screen, and it's always the same home screen. So no matter where you get lost in the menu tree structure, you can always back out by going to the bottom and hit the close button. And that'll take you back to the previous screen. And if you keep hitting close, you'll finally get back to the first screen. So that's just an easy way to back away from, I don't know where I am, and let's start over again. And there's not too many layers of screen, so it's not too difficult to do that. Okay. The other thing is calibration. Let's talk about calibration before we do it. I suspect most of you have already gone through a calibration stage and cursed it and didn't understand it and didn't do it right the first time and forgot to erase it before you started again, that sort of thing. But one of the things I found out was I have multiple calibration modes based on how I use it. And so I don't have to go back and recalibrate each time I use it. So for instance, this screen right here says 50 kilohertz to 30 megahertz. And this is the one I use for all my multi-band antennas. Not that I have that many multi-band antennas, but I have 3 of them. And so you can look at the whole spectrum of the antenna, and then you can drill down into the individual ones and look at each band. And what I've found so far is that by looking at SWR, even if I use the calibration point here, The only problem I run into is the fact that you have only so many sample points. There's 101 sample points. And if you try to look at, let's say 40 meters on this chart right here, what you find is that if you look at where the marker is right now, this thing's got 100 points calibrated or sampled. If you look at it, it says in the upper right-hand corner, 6.938 megahertz. So that's below the 40-meter band. And if you go to the next step up, you'll notice something strange. I can get it to go one step. I'm going to try to make it, it should go. Yeah. There's the one step. See, there's 7.238. So you're blowing a whole 40, you can't see the 40-meter band because you got 2 points far enough apart. But if you take it down and go to the 40-meter band, let's say you want to look at your 40-meter antenna and say, you know, did I get the resonant point inside the 40-meter band? You may find out, like I did, that you didn't quite make it. But let me take you down into that one as an example of one of those measurements. But before I do that, let me back up a little bit. If you look at this screen, what you see on here in the upper left-hand corner, the okay, first of all, there's 4 traces. You got 2 traces that show up on this side and 2 traces that show up on this side. Okay, and they'll show you the data. This one's set for SWR. Okay, and it'll show you what the SWR is. It's 1 per, let's see, per line, basically. This is 1 to 1, 2 to 1, 3 to 1, 4 to 1, etc. You can change that scale if you want. I've just left it this way to make my life simple. And then here's the SWR at 7.238, I think. It's 2.26, okay? And you see it's above the 2 line, and you can just kind of guess about where it is, okay? So that's what the screen's all about, and it'll tell you what the traces are doing. And you'll see that I've only got 1 trace running right now, it's on set on SWR. As you put multiple traces on, you will find that they'll come out. Let me go ahead and do that. Go to display. Okay, and let's put another trace on there. Okay, there's a log mag trace showing, and I got to make sure it's on the right channel. I'm going to get buried in this detail here. So okay, so what that tells you is that this color trace is a log mag, it's a log magnitude trace, 10 dB per division, okay? And it's 8.49 dB. And that's basically a return loss, okay? And what you'll see is that the return loss is the best at the resonant points, okay? And here's the best SWR point on this curve, and there's the best return loss. So these curves are actually the same math. I'm sorry, the same kind of notion of the reflection coefficient. SWR is just a different way of representing it. You see these curves look a lot alike. Okay. Well, the only point I'm trying to make here is that you have a definition of what the yellow trace is and the value. And here you have a definition of the magenta, I guess it's cyan, trace, and what it means and what the value is. And you can put all 4 of them up and you'll see them written up here in the top left and right portions of the scales. On the lower you'll see the frequency span typically of what you're taking a look at. So that's the way to read the first order, what's going to be on the screen and where do I look to try to find it. Okay. Okay, let's see. Before we dive into the single band versions of it, let's talk about calibration for just a minute. Is there anybody here that's got a VNA that has not tried to do the calibration? Okay, so it sounds like we have, at least you've gotten into it to a point to understand it partially and maybe completely. It's the basic idea is that you've got a certain number of data points on the screen and you have to set the scale. And if you're looking at a graphical screen, such as the, let's take the Smith chart here for just a minute. There's a Smith chart. Don't worry about the details. But the point is, if you look at that chart, it shows you the resistive and reactive components across this frequency band of that antenna. The point I'm trying to make is there's a scale there that goes from a short to an open and resistance along the horizontal line in the middle. So on the left is an open, I remember right, and on the right is a short. And in the middle, the very middle of the chart is 50 ohms. So you've got to calibrate that scale for the frequency range that you're trying to operate over. And that's what part of the calibration is all about. And there's two parts to the calibration. The open, short, load part is for a one-port measurement. For two-port measurements, you have to include those three plus an additional two, which are isolation and I think it's a loss between the ports, because you now you have 2 ports active. So you're trying to measure loss and gain and things like that. So it's a slightly more complicated calibration process. But for SWR, return loss and things like that that you're trying to measure on one port, you only have to do the open, short, and load. You don't have to do the connected through and the isolation to the second port. But the calibration, you don't have to do it as often as they imply that you need to do it. I have mine set up for the measurements I'm going to take, and I've not found it necessary to repeat the calibration after the unit's turned off or I turn it back on or anything like that. Certainly, if you look at the calibration when you turn the unit on, most of you have figured out that the calibration that you originally do is stored and comes alive again when you turn the unit on. And it goes, if you look at the left-hand part of the screen here, these, I mean, point the other direction, I guess. This is calibration. Capital C there means that you're calibrated and you're using the 0 slot to get the calibration points of the frequency span and the number of slots or number of samples over that frequency span available. And then you see DRSTX, and those stand for the open, short, transport, and isolation. And that's what that's all about, okay? Do we have any questions on calibration we can pick up on the way through this thing? Anybody got anything they want to talk about on calibration?
Remember to unmute your microphones if you have a question.
I think this has been very thorough so far.
Okay, well, I'm certainly willing to stop at any point and go into any level of detail, and we can come back around on the Q&A session to anything that we didn't pick up that you'd like to get a little bit more data on. So we'll do that.
Hey,
Okay.
Lee, have you played any with the Nano VNA Saver software for the PC?
Well, since I have a Mac and it's a little bit more problematic on the Mac, and I haven't, and to be honest with you, I haven't found the need for it. So, and that may be heresy, but I haven't found the need for using that software. And everything I've tried to do so far has worked out that I just didn't have to. Oh, come on, I'm trying to turn off a trace here. Excuse me.
Yeah,
just one
there's
second.
certainly situations where it's not practical to do, to log along a PC and all that kind of stuff. But the calibration with that is very, very easy when you do the VNA Saver.
I was hoping that was the case, but no, I don't have. I know enough about the saver to realize that it has certainly the one thing it does do is it allows you to separate all these screens into multiple screens, so you don't have overlays of a Smith chart on top of an SWR chart, and that would be wonderful. But I haven't really gone into
A
it.
27-inch monitor also makes it a lot easier to read.
Well, I'm blessed. I'm one of the guys who had cataract surgery and went for a nearsighted and a farsighted lens, and made the lens that I use close an 18-inch instead of 12-inch distance. So I've got a 4K screen here, and my eyes are pretty good. And I had not had too much trouble with the VNA, and I didn't see the sense of using the saver in detail when I'm trying to look at something and I'm outside on the antenna. The VNA seemed to do the job fine outside, and I just didn't need a PC, and I just never got to where I figured out I needed a PC to get any more detail. So I haven't found a use case for me that makes too much sense, but that doesn't mean that, the software is really good. It does a nice job, and I've heard nothing but compliments on it. There's also versions of that kind of software available on the Android cell phones. And I don't know if there is on the iPhone or not, but I've spent much more time on the unit itself than I have on the external software. That's a long answer, but that's where I was parked on it. Okay, reference plane. One of the things that I've done with this is to realize that the reference plane is a useful notion, and I thought it might be useful to kind of talk about it for just a minute. When most of you have done your calibrations, you've done it right on these SMA connectors. Some of you may have done it, with leads that are a certain known distance that you want to measure a filter. A lot of filters, like the one I'm going to measure later, are long enough that you need an external cable. You need to cancel that out, especially if you're working in the VHF and UHF ranges. But if you take the device under test, let's say the device under test is your external antenna, and you want to look at it as if you're at the antenna. You can go out on the antenna and pull the coax loose and use that as your calibration point and extend the device to look as if it were looking at your antenna with the device outside instead of at your shack. So you can move the plane of reference, it's called, for the measurements to almost any location you'd like to move it. So you can move it, across the room. You can move it to another unit. You can move it, outside of the antenna at a different point. So that's the notion of the reference plane. And if you look at the next thing, which is kind of the setup process for almost any measurement you want to take, it kind of follows a pattern of, okay, where do I start setting up this measurement? Whether it's SWR, return loss, let's say you want to look at a Smith chart, you need to start with, okay, what traces do I want to see? What formats do I want to see on those traces? Like maybe you want to look at SWR, maybe you want to look at reflection coefficient or return loss, and maybe you'd like to look at the reactive side to see what kind of matching you might need to do with the tuner. You know, as an example, if you're using a tuner, a Smith chart is really nice because you can actually see the knobs, the capacitive and inductive variables change and rotate the Smith chart towards the center. And it's a really intuitive way of giving you feedback as to which direction do I need to go in to get to resonance. So the setup process says set your set up the individual channels, set up the traces, how many traces you want, set up the channels you want those traces connected to, because you can connect the traces to whichever channel you want, whichever port you want. Okay. Then you do the calibration. Once you've got that in your head, then you do the calibration because you know what frequency span you're going to operate on, you know what you're looking for, you know what scales of division you want to have on SWR or some other chart. Okay. If you want to scale the Smith chart to 75 ohms instead of 50 ohms, you know, you got some things there you can do as well. So once you get that done, then you do the calibration. Okay, and then you get the device unit, the unit under test, and hook it up. Add whatever markers you want. You might want to put markers on the band edge. Let's say you're looking at a 40-meter dipole, and you'd like to look at how it's doing on 40 meters at 70, you know, 7 megahertz, band center, and then top end at 7.3. You can put markers on there. You see the marker on this screen, it's marker number 1. It shows you what the SWR is at that marker, and it shows you what frequency that marker's at. So that's the utility of the markers. On some of the newer software packages, or firmware packages, I should say, on the nano VNAs, you can actually ask the marker to go to the minimum SWR point, and it'll go there. You don't have to actually move it with a pointer. Okay, and then you can adjust the traces as you see fit after that to finish up and tweak up whatever measurements you want. But that notion of starting with defining the traces, putting the stimulus in, making sure your calibration has either already been done before, you don't have to do it again, or set up and do it because you're using a different, let's say you're measuring your walkie-talkie antenna at 2 meters and 70 centimeters, and you're set for a 50 kilohertz to 30 megahertz scale. Well, you're going to have to recalibrate them. Okay. But that's the kind of notion of a setup process that you kind of get used to, and it's kind of a routine. It's almost like muscle memory. Okay. Let's drill down, take this chart into, let's say, looking at a 40-meter band. This is an antenna. This is an 80-meter hand-built antenna. I used Steve Ellington work that he's put on the website. I wish he'd come back on his Facebook page, by the way. I don't mean website. He's taken a break for a couple of months, and he's I don't think he's really back active again yet. Anyway, but that's what this antenna is, and I used his instructions to wind the coils and everything. And so let's take a look at see where it ended up at on 40 meters. So if I go take a look at this, and again back up like I said, okay, there's the stimulus, and I'm going to set it for, let's say I want to use the center setting at 7 megahertz. Oh, come on. I'll get it right in a minute. 7 megahertz is center setting. And then I want to set the span up for, let's say, a megahertz on either side. Okay. So I'll make it 2 megahertz. Okay, and that's what this antenna looks like. Center sitting on 7, and you'll find out the ugly secret of my antenna. It's not resonant, and it's not at the resonant point, exactly resonant in the 7 megahertz band. It's resonant at about 6.9 here. It's down here. Okay, this is 7 megahertz, and there's where it really is resonant, and the SWR down there. Well, let's take this one. This is at 7. Take it up to 7.3. Okay, and there it is at 2.35 at 7.3, and at 7 megahertz. We'll slide it down. And there's 1.772. Okay. The good news is that it tunes less than 3 to 1. So my 7300 will tune it without an external tuner. My objective in using this particular antenna was no external tuners. And that seems to work out pretty well. So I haven't had to go tune this antenna to move it around very much. Mine's hanging up in the trees, and it's a little tricky to get it up and down without having a few headaches along the way. But there's just one marker I've put on there, and you can add other markers, and I think you've probably seen how to do that. But again, you go back and let's see, there's marker, and you can put, let's see, I can't read my own screens here. You can start a marker, select one called marker 2. Okay, and so you can just add them on there, and then you can move them around and put them where you want to go. My software or my firmware doesn't allow me to have the marker controlled to look for the minimums because I haven't upgraded the firmware yet. But if you look at the minimum on this antenna, it's down around 1.65 at 6.9 megahertz. Okay, so that takes you through looking at the antennas, and most of you have, if you've spent much time on your VNAs, you've already gone through this, and so you have a sense of what it's all about. The other thing I've done here, let me give you an example. Let's put this at the band, put these markers at the band edge here. Almost close enough. Okay. One of the things I've noticed on some of these antennas, such as the off-center fed antennas, the resonant points are pretty broad, so you don't get a real good sense of what they're like necessarily. And so one of the things that I've done is added some traces to show you different things. And we'll take a look at one here. And I'm going to add this trace here. If I get the right trace, I'll be all set. Format, clock mag. Okay. And then the other trace I wanted to put on here was the Smith chart trace. Okay. And you'll see that the markers follow the traces. So if you look at the yellow traces we looked at before, the markers are sitting there at the band edge of 7 megahertz and 7.3, and you can tell the scale, and it's pretty obvious that, okay, 7 is the center, and 7.5 is the first vertical line to the right. So that must be 7.3. The cyan trace above there is the return loss. And it's not quite as sharp on this, and I'm a little bit surprised. But it's also marked, and it looks very similar to the SWR curve because they're the same basic fundamental math. If you look at the green trace, that's the Smith chart. And you'll find that if you look at up here, you'll see the marker. It's 28 ohms, I think, 28.4 ohms and 553 nanohenries. Okay. That's where the, let's see, I believe that's that marker right there. Okay. And so here's the movement along the Smith chart for the 40 meter band. And this is the 50 ohm resistive part of the Smith chart. So you can tell this is inductive by the fact that it says nanohenries, but also it's up in this part of the chart. And so it comes off the 50 ohms, and you see, since this is a short, if it's purely resistive, if that's a short, then you'll see this is the 50 ohm point right here. Okay. So I'll give you some idea of what the Smith chart looks like and the fact that it's staying in the middle. A trick on the Smith chart is if it's within a circle about like that in the middle, the Smith chart is concentric SWR curves. Let me back up. The Smith chart is a series of concentric SWR curves at the integers of 1, 2, 3, and 4. So you can see them. They look like larger circles building out. And so if you're in the center of the Smith chart, that's where you want to be. If you're out here on the edges, your SWR is 2 to 1 and 3 to 1. Okay. So this gives you an idea of how to look at an individual band on an antenna. If you look at some of the other bands, they look a little bit different. But this is the fundamental part of drilling down and looking in detail. And you can see that this is off, as I said, but if you look at the other bands, they're pretty close to being on. And so the question is, on a multi-band antenna, what do you do about that? And in some cases, you end up leaving it in place. If I get this thing right here. Set this up and go up to 20 meters. That shows you what the 20 meter chart looks like. Okay, and that goes from 14 megahertz in the middle to 13 on the bottom and 15 on the top. And again, the same curves gives you a sense of what's going on there. Okay, so I think this is enough of that. Let's take a look at looking at the filter. This is a 1-port measurement, and the filter is going to be a 2-port measurement. And we've got the take me too long to hook it up here. And basically what you're doing is you're taking 1 port and using as a signal source and a reflection part. So you can tell, what you can put the stimulus in that port, you can, or from that port, you can then look at the SWR going into that filter as a reflection coefficient and get an idea of, do you have a good 50 ohm load there for the filter. Okay. All right, it's connected. Let me go ahead and set it up here. Let me turn some of these traces off. Okay, let me, since we're looking at an 80-meter filter, it's going to be a little tough to, or 40-meter signal, 20-meter signal, look at it. Okay, we'll start this thing at, let's say, 3 megahertz. And we'll go to 4 megahertz with it. Let's go to 5. Just to give us a better perspective of what we're looking at. Okay. So there's the okay. Now, I'm a little surprised that the back up and look at one of the other. Okay. That wasn't exactly the curve I was looking for. Oh, I know what the problem is. Okay, there you go. Button pushing. All right. Well, I have now confused myself. I was trying to set this thing up for a through measurement. And I got channel 0 and I got channel 1 with a log mag, which should be the through part. Okay, what am I doing wrong?
Have you paid the tax to the demo gods?
Yeah.
Obviously not.
Which filter do you have on that you're testing?
I've got the,
Oh, something just changed.
oh, you know what was wrong? There was a connection bad. Thank you.
There you go.
Here I am in Panicsville trying to figure out what I'm doing wrong. And I have a connection that's wrong. Well, that looked like a connection problem because that was the right trace.
I hate to say it, but I think one of your SMA cables may be on the fritz.
Well,
It's fixed again.
Okay, I'm not touching it. Okay. Anyway, the yellow curve is the SWR curve. So you see it's a good match in a lot of the passband, because the left vertical is 3 megahertz, 3.5, 4, 4.5. So here's the band, 3.5 to 4. Okay, and notice the frequency response in that passband. This should be 3.5, so it's got that edge. Okay, but look what happens up here. It's down. Let me move the marker so we can see what we got to work with here. So what that says is you're about 4 dB down, 4.5 dB down, close to 4 megahertz. So you got a pretty lossy filter in the high end, in the phone part of the band here. And if you go up here a little bit further, that gives you an idea what the loss is there. You got 1 dB loss through that filter. Okay. What you can see, you get a really nice set of curves. You got a good idea what the filter looks like. You can back away from it in terms of scale. And let's say you want to take the span out to okay, that's a wider span. Or you can my point is, you can go on down the curves, go down these curves and see what kind of projection you have. This is 10 dB per division, by the way. So there's 10 dB down, 20 dB down, and 30 dB down. Okay, so it gives you an idea what you got to work with. And you can change the scale to, if you want to, instead of using a center frequency like that, you could pick the starting points on stimulus to start anywhere you want to. Let's say you want to see what this filter does at 40 meters because you're concerned about the second or third or fourth harmonics coming off this transmitter. You want to see what kind of rejection you got. You can just let's say you want to start it at let's say 3 megahertz. Oh, come on. Start at 3 megahertz and going up to, let's say, 14 or so, just to get an idea what you got up there in terms of harmonics. So that gives you an idea. You can just plot along this curve and see where you are. And you'll see the numbers changing the upper right-hand side in terms of, what frequency you're at, and get an idea what that filter looks like. But that's just an easy way to look at a filter. Those are bandpass filters. And I was surprised to see that they had, I guess I'm not used to looking at these filters, but a dB loss seems kind of high to me for a passband for a transmitting type filter. And certainly I was surprised to see it roll off at the phone part of the band, and it really takes it down quite a bit. So, okay, let me shut up a little bit and let's start talking about Q&A, if that's okay.
The problem is that that's a fairly high Q filter, and the bandwidth around the low loss point is not that much.
Uh-huh.
So I mean, you have to, it's always a compromise depending on how many poles you have in the filter, how wide it is that it's flat, and then how fast it falls off. So, you know, it depends on how you design the filter, and this is probably a relatively inexpensive filter.
Yeah, I
Well,
think
it wasn't, it
it
wasn't
wasn't by,
exactly that.
it wasn't by, if you look at what it cost. Right, Dallas?
Yeah, the manufacturer of this thing claims like less than a half a dB loss, typically 0.3, 0.4. However, this one was used at a field day site and left overnight. And we think somebody changed the band on the radio and transmitted it for who knows how long until they finally realized the radio just was not working right. Well, at the wrong band, that filter becomes a short. So they transmitted it at it long enough that they have most probably fried the capacitors in that beast. Maybe even done damage to the ferrite cores themselves. But it should not look like this.
Anyway, yeah, the other filters don't look this bad, but this one's seemed to be out of sorts. Okay, why don't we shift out of my trying to get my broken connectors fixed to any questions that you folks have that we can either demonstrate, talk through, or try to answer at a later date.
Just a quick question. Is this one of the GARS filters that we use for field day?
It's very similar. This one's one of that's mine, and it was given to me by a ham in Texas, and it's a Dune Star. You know, they're one of the, I'd say, top 5 manufacturers of selling these things. But I think the head guy who designed these, I think he's now a silent key. So this one here may be just cannon fodder for now.
Yeah, and what I'm thinking is it would be fun to take a look at the GARS, you know, our official club filters that we've had for ages. And I know I engraved the bands on them years ago because even the labels had fallen off. But it would be fun to see, you know, if any of those, you know, capacitors or toroids had been saturated. So just a thought, and I'd be happy to do that. Whoever has those filters.
I have those and I'll get in touch with you, Brian.
Okay.
Yeah, I remember using one of those filters, not this winter field day, but last year's winter field day when we were still meeting in person. And they were doing a pretty good job of fending off some of the strong CW signals on a different band, but they were doing a pretty good job of protecting. Unfortunately, it wasn't getting all of it, but it was getting most of it. I think we were just too close proximity for the bandfast filters to be completely operable.
You have to remember filters, those filters, they only, unless you're going to pay the big bucks, they won't make a filter for you to cover just the CW band, so that sideband on the 40-meter band will interfere with you. That, you know, real narrow. So these cover 40 meters, 7 to 7.3 and or 7.4 if we're lucky. What it does is supposed to keep out adjacent bands. And if you have proximity, RF proximity in there, nothing will filter out if you're too close.
Yeah, I think that's what was going on, David, was the proximity.
Yeah.
Because I think they were transmitting on like 20 meters and I was on 40 or vice versa. And the filters were reducing the problem, but not completely eliminating it due to the proximity.
Yeah, there's probably some coupling directly from rig to rig that it's, yeah, they're not fully shielded either.
Anyway, it'd be a fun thing just to
Shielded,
check
you
them.
wouldn't be able to communicate.
Well, I'm just saying, if they're perfectly shielded except the coax connector, and you have good shielded coax, but it's not 100%.
Yeah.
And they have to have both stations or all stations at a field day site really has to have a filter. Otherwise, you negate the whole purpose. It's all or basically none.
I'm amazed we're able to do as well as we do, whether we have like, 4 stations or 8 stations out there. I think this has worked out pretty well over the last couple of years that I've been involved with GARS. And I know a lot of you folks have been much, much longer than me.
Well, if you ever visit somebody that's got a true contest station and they have a set of filters, you will be surprised at how much they can do and not nuke the other station, and including running power.
Lee, I have a question for you. Lee, if you can hear me, if got a question for you.
Sure, absolutely.
All right, when you calibrate, and I've set up several for popular bands, some limits outside the band. But if you calibrate over a wide distance and then just set your sweep for the smaller, is that still accurate?
No.
Let's say I calibrate for 3 megahertz to 30 megahertz.
Right.
And then I recall that calibration, but then I set the sweep for just the 40 meter band or the 20 meter band.
Mm-hmm.
Would that be valid?
Well, let's think about it for just a minute.
Or do I need to calibrate for the smaller segment of the band or whatever I intend to measure, really?
Well, everything you've seen tonight was done with no new calibrations for a smaller scale. The calibration I've got here running tonight is the 50 kilohertz to 30 megahertz calibration. Okay, so when I looked at the individual smaller bands, I didn't recalibrate. Okay, so I think the answer is, unless you're going crazy with, starting on 160 and maybe doing something at 1296, I don't think it's that big a deal unless you're trying to be very precise with the measurements. But for most of us, you're just trying to work the SWR and see where you are and tune an antenna and move the resonant point around. And I haven't found it necessary to recalibrate outside this because one of the things you got to remember, and I keep forgetting this to mention it, is whenever you turn the unit off, the only thing that's going to come back is that C0 memory location for the calibration parameters. So if you've calibrated for 0 to 30, let's say, and you've in the meantime calibrated something else, but you didn't save it into the C0 location, it's going to evaporate when you turn the unit off. Okay, so don't forget that. So you only have one storage location that is going to be remembered by the firmware and come back up as calibrated in that particular point. And since most everything I'm doing with tuning antennas is in the HF range, 50 kilohertz to 30 megahertz has served me well. And I haven't found it necessary to go back and recalibrate on an individual band from that 30 megahertz calibration point.
So if I've stored something, if I've calibrated, let's see, C1 for the 2 meter band, or let's say 140 to 150, when I power off and come back on, if I recall 1, I'm not getting the stored data. Is that only in C0?
That's my understanding.
Okay, good point. Thank you.
That's one advantage of using the PC software is you can store multiple calibrations on the PC and then load them.
That is correct.
True.
That is correct.
So when I worked on that 6 meter hex beam, I did a calibration just for the 6 meter portion.
Hey, Lee, another question on the,
Sure.
the connectors. When I started, really digging into this, the advice from the pros is to use the those little SMA torque wrenches, because they claim that your calibration would be different if you just you know, if you don't have the exact torque for the SMA connector. I have never done, well, I took a look at the price of those things and they're like $100 for an SMA torque wrench. I decided my thumb was good enough. I take it you're not using an SMA torque wrench either?
No, not at all. And I think the problem you got is that a lot of people are talking about nano VNAs came from the world of the $200,000 VNA, not $200,000 network analyzers that they used at work. And, you know, they're in a manufacturing mode. They're worrying about hundreds of dB at 20 gigahertz. You know, so remember, some of the people talking about this stuff are precision manufacturing guys looking for tolerances and costs and things like that. So to them, you know, a torque wrench for $100 is no big deal. And it ensures that that's one more thing nailed down they don't have to worry about. So, but my point is, there's a sensitivity range for talking about things like the torque wrenches. And I don't think in ham radio, they have much of a place.
Yeah, and I kind of thought that it was, you know, maybe it's relevant to, you know, very high gigahertz ranges where, you know, a half a millimeter difference in how deeply the SMA connector is inserted might make a difference that, you know, wouldn't be even detectable on 40 meters or even
Right.
15 or 10. So
Right,
that was
right.
my rationale for avoiding any additional cost.
Well, remember who you're talking to tonight. You just saw a guy fumble with an SMA connector tonight because he couldn't get it right. So maybe a torque wrench would have helped me out tonight.
One question on the calibration.
Sure.
One of the things that I understood is if you wanted to save calibrations that you had done. So what I did is I saved one, I left the C0 remaining what the factory was, and I saved C1 as being 3.5 to 30.
Mhm.
And C2 is 144 to 148, and then
Right.
C3 I think I saved for the 70 centimeters.
Right.
So each time I want to do an antenna for those particular frequencies, I just recall that saved value, and that calibration is then installed into the VNA and it's still calibrated from what I understand.
You mean a standalone nano VNA?
Yes.
Because I don't think that, I'm not sure that's the case.
Yeah, there's
I think it depends on the version you've got on the firmware.
Oh, you're right.
Because
Okay.
on mine, I have, the one I bought was the version 2. And it's the one to, 3 gig, I think it is.
Right.
And and I bought it from what is RNL or whatever. It's the one with it actually came with the end connectors.
Right.
And when I went online, they have a manual and a group and all sorts of, and it has 7 storage points, and I have each of the 7, and it was uncalibrated. Yeah, well, if you look when you're in an uncalibrated point, the side turns red.
Mm-hmm.
And when it's calibrated, I guess I mean, my eyesight's not good, but it's a greenish color.
Right.
So, and when I save a calibration and bring it back, it says it's calibrated.
Right.
Well, I think the further versions of firmware have added calibration points. But if I'm not mistaken, the one I've got is the original starting point and in the firmware. And I think C0 is the only one that's stored once you turn it off.
Okay.
As the newer units, I think, will store more. And I think that's probably, there's a couple of manuals out there that are written that I referenced in the presentation that, beginner's guide to VNA and stuff like that have detailed explanations on the calibration side. And if I'm not mistaken, I have seen in some of the future versions of the firmware, and certainly the H4 unit probably stores those, but I'm not sure because I don't have that firmware, and I didn't. My research is from my scattered brain remembering what I read as opposed to,
Hey,
I looked at it for sure.
Lee.
Yeah.
I have the H4 version and it stores 5 calibration points.
Okay, all right, good.
Yep.
And I have the original version, it stores 1.
And on the version 2, which is I guess a slightly different for hardware and firmware, it seems to store, I think, 7 or 8 points.
Mhm. Okay. Well, that's the nice thing about the firmware moving along. And it's a really nice piece of firmware. These guys have done an awful lot of work to give us something that's quite this flexible. And it scares a lot of people at first, but I think most of you have seen that it's manageable. If you put some of the muscle memory to work and just remember a few things to make sure you didn't forget. Well, I've been
And
thrilled with mine, and mine's the original version, and
And
small screen.
Also, the big thing for me is to make sure that in each storage, you only bring up one screen, one trace at first. So you don't, if it comes up with 4 traces, you're sort of useless.
Well, I think all of us had the same reaction when we turned our VNA on the first time. It's like, is this a clone? Is it broken? Why do I have all this crap on my screen?
Yeah.
That was my first thought, that I had a bad unit.
It took a while to figure out how to turn off the traces.
Yeah, well, and a few of us went through Chinese to get there.
I'm lucky. I think maybe from when you started to now, some of the documentation online is probably improved.
Oh yeah, yeah. When I said went through Chinese, what I meant was there's an option to show it in Chinese. And if you hit the wrong options, you're in the wrong language. And once you do that, how do you read that language to make it go back? That was my problem.
You look at the chart of the positions and you count.
That's exactly right. And you pray that you have a good unit to start with.
Really appreciate the time you're taking the time to help
Sure.
us.
And by the way, if there are any questions that you guys, any of you come up with later, I'm on QRZ and then my email's there. I'll be happy to help out in any way I can. I think it's great that y'all took the time to buy a unit, look at it, and I think I'd be surprised if any of you felt like it was a bad decision.